Good afternoon, gentlemen, and we're back. We finished our filtering step, and I've divided our solutions and split them up among two hot plates here, and the reason being was the volume of the solution was starting to grow. So what I have in front of me is two 2,000 milliliter beakers. The one on the right has about 1,200 milliliters of solution. The one on the left has a little over 1,000 milliliters of solution. We have our pH probe and test meter over here to our right. Down below me, what we have is the filters that came from the hydroxide solution. And if you'll notice, there was a lot of iron in that. And you ask yourself, well, how would iron get in sterling? Well, remember from the beginning I wasn't using sterling. I was using recovered silver that I'd used for silver cells previously. Well, the way that I recover that silver from the cells is I cement it on copper. Well, you ask yourself, where could all this iron come from? Well, as a refiner, I don't buy brand new copper just to dissolve in the solution. I don't know, what is it, $2, $3 a pound or something now? That don't even make sense. When we dissolve as much copper as we do, we can recover some of that copper. And before I treat my waste for disposal, we'll put steel inside of a copper solution to cement the copper out of it. And then I take that copper powder and I wash it. But what happens is, just like when we precipitate silver with copper and we get some copper trapped in that silver, whenever I precipitate the copper from the nitrate solution with steel, we wind up with some iron trapped in it. So when I precipitated all this material that we started with here, I used that type of copper powder. But in that copper powder is a certain amount of iron or steel, and that's what reported to our filter residues here. Now, after I done the hydroxide step and I filtered it the first time, I let it sit overnight and I went to filter it again and I noticed that some more hydroxides had precipitated out of solution. So the hydroxide step is one that it takes some time. Now when we adjusted the pH of our Formate solution, we only had two chemicals to contend with, formic acid and sodium formate. But whenever we use sodium hydroxide to precipitate these metals out of solution, we have all kinds of metals, we have all kinds of side stream reactions that are going on, and it takes a while for the equilibrium of the solution to balance out. And that's the reason we was having some problems with our pH testing, as it would go up and as it would go down. It's because at the same time that we're trying to do that, the chemical solution is trying to balance itself out. So you've got a lot of chemical reactions occurring. So after I let it sit overnight and filtered it again to remove any more sediment that may have been in there, it was still kind of cloudy. But once I placed it on the hot plates and started bringing the temperature up, because we want our temperature to be 140 degrees for this step whenever we precipitate it, I noticed that the clarity of the solution started to get better. And then I added about 10 milliliters of nitric to each solution, and what happened was those hydroxides went back into solution, and these solutions are now crystal clear. And if you'll look, you can see how clear that this solution is. You can actually see the bottom of the beaker there, and you can see straight through the solution. Well, there's a little more clarity. Well, what we're fixing to do here in a minute is have our saturated sodium formate solution up here. And we're going to add that to our silver nitrate solution to precipitate our pure silver out. And down here we have our pH meter, and this is going to be the last time that we use our pH meter. After that, we'll be tested with salt water to see how much silver may be left in the solution. But what I'm going to do here is I'm going to go ahead and show you what the temperature of this solution is, and I'm going to show you what the pH of this solution is. Now the pH didn't quite, it actually rose more than I wanted it to. Our pH at the present time seems to be sitting around anywhere from 2 to about 2.3. The difference between these two beakers is only just a little bit. But I'm going to go ahead and we're going to precipitate at that range. Formate said 1.5. Some of the other patents I've read say 4 or a little higher. So I still think I'm within the margin of error. But that's what learning any new process is just being very observant and learning what to do and what not to do. So let's go ahead and let me move this out of our way here. And we'll come over here and get our pH meter. And we'll turn it on. And we'll stick it in the solution and we'll give it just a minute for it to go ahead and balance out. And our solution's at 140 degrees. And the pH is at 0.4, 0.6, 0.7. And it's starting to rise. 1.6, 1.7, 1.8, 1.9, 2, 2.1, 2.2, 2.1, 2.2, 2.1. So as you can see, we're right around the 2 mark. And at 140 degrees. Now let's go over here and check our pH. And we're at 135.9. And you have to give this pH meter to adjust when you go from one solution to another like that sometimes. And it seems to be stuck at about 2.5, which will kind of give, well, 2.4. It'll start to drop after a minute. I think I was down around 2.2 a while ago or something other. But what this will do is it'll give us a difference between the solution pHs to observe the reaction, so we can actually learn from this. So, go ahead and shake this off and place it back over here. And that'll be the last time we see Mr. Happy pH meter right there. So, let me see. Let's zoom out a little bit. And I'm going to turn these beakers to get these numbers out your way so you can see what's actually going to happen in here when we start precipitating. That way you'll be able to get a pretty good side shot view. And if you'll look, that's pretty clear in there. You can see the stir stick moving around. The same over here. You can see the pyrocrene dish through the back of it. And you can see the numbers. So, how much sodium formate do we need? Well, we don't exactly know that. What we're going to do is we're going to add sodium formate solution to it. And we're going to check it after we think we've added enough. Work the sides of these beakers down here. Always use distilled water, remember. Let's see the clarity. You can see the clarity of the solution. Now, the reason we want to add a saturated solution of sodium formate is because when we add this, we're going to have a process occur called nucleation. And the more concentrated the solution is, the larger the particle size that are going to precipitate from the solution. A very weak solution equals very fine particulate. A concentrated solution equals a larger grain size, which should wash a whole lot easier. So, what I'm going to do now is I'm going to stir this just a little bit. Get it uniformed. And we're going to take some of our sodium formate here, and we're going to see what happens. Interesting. In case you didn't notice, it turned black as it hit the bottom. Alrighty. Let's add some more. Alrighty. I'm going to let that set for a minute and cut away, and we'll give that just a few minutes and come back to it. Okay, gentlemen, we're back, and I know this ain't where we left off at, but I had to do a little bit of experimenting here the first time to see how this worked. But what we're looking at is the silver as it drops out of this solution. And it's fizzing, and if you look, it looks just like a gold precipitation. I mean, it is snowing silver out of this beaker. And at the same time, it's foaming on the top, almost like it had too much nitric acid in it. I'm not sure what that is. It's going through multiple stages of that. But each time that it does it, I've noticed that it snows silver, so it's the chemical reaction proceeding. And I had to add quite a bit of sodium formate, and the reason I had to do that was because I added some nitric earlier to adjust the pH, and then as I was adding the sodium formate, you was seeing the silver precipitate out. But like in gold refining, if you've got any excess oxidizer, it's not going to precipitate. So now that the chemical reaction is started, I believe you could see that is some pretty silver, and it is just snowing silver in this beaker. The bubbles are going through patterns. About every 10 to 15 seconds, the bubbles will rise up to the top, start foaming, and it's a new wave of silver that starts to fall from the solution. Now, I've had to do a few tricks with this along the way, and I'm going to test all this when I'm done to see what my purities are, but I think we've come pretty close to achieving the results that we're trying to achieve. Now, back over here, I haven't forgot about y'all. I still have the clear solution, and I was saving this one until I figured out what I was doing with the other one. So here in just a minute, we're going to go ahead and we're going to precipitate the silver from that also. But back over to our beaker, we've still got a chemical reaction going on, and it's still snowing silver, pretty silver. And you can see it coming down like fluffy white snow and laying on the bottom of the beaker. So we're going to cut away and let it snow here for a minute, and I'm going to switch back over to the other beaker, and I'm going to show you how we precipitate that out. So give me just a few minutes, gentlemen, and I'll be back with you. Okay, gentlemen, we're back, and I've got everything set up for us again over here. And it's been about 10 minutes now, so I'm going to swing around here and show you what our silk looks like. And if you'll notice, we still have silver rising and falling, but what that is big clumps of silver. And this solution is off-gassing, and that gas gets trapped in that fluffy silver and makes it want to float. So let's look on top here, and if you'll see, we got these funny looking little, see, you can still see the solution bubbling as it's off-gassing. And what happened is I added, and it kept going back in the solution, which you'll see here in a minute. So I just decided to over add. and it seems that we've got a continuous gas coming from this solution, and that's what's causing the silver to rise and fall. But once that finishes, this should all sink to the bottom, and I'm pretty much sure that everything is precipitated from that solution by now, but we're going to test it just to make sure. And if you'll look, it even precipitated on the beaker, just like it does with gold sometimes. And let's see if we can get a little bit of a zoom in here. And you can still see it rising and falling, but the precipitation step is pretty much done now. That's just coming from the gas. So let's go over here and let's try to show you again what this looks like. And you can see our clarity here. And a while ago I took my pH meter whenever the silver started precipitating from the solution. The solution pH was about 4 to 5. So the pH has to rise before it starts precipitating. So let's try getting a good focus in here. I don't know if I can get a good shot from the side or not. That may work for y'all. And I want to give you some reference here to go by. And I'm going to start pouring this sodium formate solution in. Now, I'm not going to measure this. I don't pay much for these chemicals. When you buy them in bulk like this, you should be able to get the sodium formate for about 80 cents a pound. And you should be able to get the formic acid about $1 a pound, and the sodium hydroxide's about 56 cents a pound. So there's only 1 3/4 pounds dissolved in this whole 2 liter right here. So at the most I'm going to use $1.50 in sodium formate to precipitate this. So if I use a little bit more, it's not that bad. And if you'll notice, the solution turns black, but then it turns clear again. And that's because I probably put that excess nitric in there to clear them hydroxides up. So it's causing it to go back into solution. So let's just pour freely. And as you can see, the whole solution just turned ink black. And let's give it a moment here. Let's pour just a little more in there. And we'll give the process a minute to start. That's what happened a second ago. And as you can see, we've got some bubbles trying to form on top. Let's stir it a little bit to get the solution mixed up good. And sometimes it takes a minute for these chemical processes to start occurring. Add just a little more in here. And voila, you can see the silver starting to precipitate out. That's what that is, the swirls of real fine silver powder in the solution. Stir a little more. And let the solution slow down. And looking at it from the side, I could see a real fine powder starting to form on the bottom. And let's move our other beaker that we have over here in my good light source, so I can set this up there and give you an idea of what's fixing to occur. And if you look towards the bottom, there's a real fine ring around the bottom, but we haven't started any heavy precipitation yet. So we'll give that just a second. Add just a touch more sodium formate to it. And we'll give it a second. When I done this a while ago, it took a minute or two to kick in, and then it just started snowing silver. Okay, gentlemen, I'm back. I had to put a watch glass on top of this beaker here. And if you'll notice on the side of the beaker, I took a stir rod and made some scratches. What happened was the whole inside of the beaker turned silver, like a silver backing on a mirror. Now, our our silver is precipitating out right now, I can promise you that, but we just can't see it through this beaker because it's done silvered up and we're not able to see it. So, what I'm going to do now is I'm fixing to cut away for just a moment. Our other solution is still over here precipitating out and bubbling nicely. And we have spongy silver in the bottom that looks like barnacles, which is usually pretty easy to filter and wash. So, I'm going to cut away for a minute, and we're probably going to let this reaction run for probably the rest of the night. I'll let it settle out, and then I'll come out here in the morning and I'll start filtering and recovering this silver, and we'll wash it and see what kind of product that we've produced so far. So I'll probably see you gentlemen in the AM sometime.